Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today we'll be simply explaining OSPF version 2 versus OSPF version 3. Just a quick reminder, I have a free 27-page Networking Professionals Career Roadmap. You can download it for free at the link below. You can also check out my website for more goodies and in-depth courses. And if you like this video and this series, please subscribe, like, and hit the bell icon. Open Shortest Path First was originally published way back in 1989 in RFC 1131. I'm always intrigued by how old many of these protocols are, and yet they're still in use today, and are expected to be around for decades to come. This is a protocol that is traversing its fourth decade of existence and is soon to enter its fifth. OSPF version 2 was originally published in 1992, but has continuously been updated and improved over the years. The current official RFC that obsoletes all previous ones is RFC 2328 from 1998. But this version 2 RFC has seen some updates or amendments, with the latest such RFC updates coming out in 2016. Now, just a quick side note, RFC stands for Request for Comments. These are official documents published by the Internet Engineering Task Force, or the IETF. They are initially shared among designers and engineers to refine protocols. Once finalized, they serve as the authoritative source for the official specifications and operational details of protocols developed by the IETF. They're freely available online and can be accessed as needed. Simply search for them. Okay, side note over. OSPF version 2 is specifically designed for use with IPv4. Now, OSPF version 3 was published originally in 2008, but it too has gone through some updates and amendments, with the latest official such updates dated within 2018, as of the publication of this video. OSPF version 3 is specifically designed for use with IPv6, but it's also backward compatible with IPv4. Now, it's easy to say that OSPF version 2 uses IPv4 and OSPF version 3 uses IPv6, focusing on the specific IP version as the main difference between the two protocols. However, although this is true, the differences between these protocols are not that trivial. There's more to it than that. Specifically, we'll be looking at the following aspects of these two protocols. First, we'll see how OSPF version 3 adds the concept of address families. This is the feature that allows the protocol to support both IPv4 and IPv6. We'll also take a look at two new LSAs that version 3 introduces in an effort to make OSPF more flexible. This is done by decoupling the IP addressing from the routing itself. We'll explain more about what that means. We'll also see how OSPF version 3 supports more robust authentication between OSPF neighbors. We haven't talked about authentication at all yet for OSPF, but here we'll see the differences between the two protocol versions. And finally, we'll see how the syntax for implementing it changes on Cisco iOS routers. Now, the address family is a feature of OSPF that allows you to support both IPv4 and IPv6 in the same OSPF process. An address family essentially corresponds to either version 4 or version 6 of the IP protocol. When you go into your routing configuration, you can issue the address family command and then indicate the IP protocol that you are using. Once in the address family configuration mode, you can then apply any configurations you need to for that particular address family. This is actually similar to the address family capabilities that multi-protocol BGP has. Now, OSPF version 3 uses much the same LSAs as OSPF version 2. However, it has also introduced a couple more LSAs. The new LSAs for OSPF version 3 are types 8 and 9, also known as the link LSA and the intra-area prefix LSA. Now, why were these introduced? Because OSPF version 3 has decoupled the prefix information from the topology information. Remember, OSPF shares information about the whole topology of an area, including links, costs, router IDs, and so on. Type 1 and Type 2 LSAs no longer contain any information about prefixes. They now only contain topology information. All of the prefix information has been moved to types 8 and 9. Similarly, types 8 and 9 don't contain any information about topology. They only carry information about prefixes. The result is that in OSPF version 3, topology and address information have been decoupled. Now, I've used that word several times. Let me explain exactly what it means. It means we separate the prefixes from the topology information. The prefixes and topology are advertised now through distinct different LSAs. This separation provides greater flexibility, allowing routers to inform neighbors only about the specific changes that are relevant. For example, if there's a topology change without any change to prefix information, only types 1 and 2, that is, router and network LSAs, are sent. Conversely, if there's a change in prefix information, but the topology remains the same, only types 8 and 9, that is, link LSAs and intra-area prefix LSAs, are exchanged. This avoids sending redundant information and optimizes LSA flooding. Now let's take a closer look at these two new LSA types, which are specifically designed to advertise prefix information. Type 8 LSAs are also known as link LSAs. These are advertised per interface and have only local significance. They contain the link local address of the interface sending them, as well as the associated IPv6 global unicast prefix of that interface. Now, IPv6 uses link local addresses to allow OSPF version 3 routers to communicate with their neighbors. This is done by design. If you're not sure what link local addresses are in IPv6, I suggest you do a bit of research and read up on it. It's worth it at this point. As you can see here, the Gigabit Ethernet 01 interface is configured with a link local address. By default, OSPF version 3 uses this address to create the neighbor adjacency. So the Type 8 LSA is sent on this link, and it contains the link local address, as well as the global unicast IPv6 prefix associated with that interface, assuming that it is configured on that interface. It does not include any topology information. Also, you can see that Type 8 LSAs are not flooded throughout the area. They remain only on the link within which they were sent. By sending Type 8 LSAs, this router informs its neighbor about the prefixes on that specific link. Now, the Type 8 LSAs also include some more information that has to do with router options and capabilities, which are indicated using a set of flags. Now, let's take a look at the Type 9 LSA. This is called the intra-area prefix LSA. This LSA also decouples prefix information from the Type 1 and Type 2 LSAs. The prefix info contained in Type 9 LSAs is broader than that contained in Type 8, in the sense that it's not limited only to the information found on a particular link. This type of LSA is flooded within an area and associates prefixes with the topology info found in either a router LSA, a Type 1, or a network LSA, a Type 2. Now let's take a look at some of the differences in authentication between OSPF version 2 and version 3. Now, it is possible to make OSPF safer by configuring authentication between OSPF neighbors. Now, OSPF version 2 supports plain text authentication, which uses a plain text password, which is considered insecure and should never be used. It also supports a shared secret key using MD5 hashing, which of course is more secure. Now, I won't go into how this actually works, but you can look up MD5 and OSPF authentication to learn more. Using MD5, of course, is more secure. However, it is still considered somewhat vulnerable for today's networks. The support for this security is natively available in the OSPF protocol itself. This means that the authentication mechanisms are actually implemented in the OSPF header. Now, OSPF version 3 does not natively support authentication in the same way, but it uses IPv6's built-in IPsec authentication. So authentication takes place at the IP layer, not within the OSPF version 3 messages or packets. For those of you that know about IPv6, this uses what is known as an extension header, which gives the option of using either AH or ESP, two particular options for ensuring integrity and encryption for authentication between OSPF neighbors. Now, all of this provides a much more robust level of security for OSPF operation. Finally, let's take a look at how we configure OSPF version 2 and version 3 in a Cisco device. First of all, for OSPF version 2, you can configure OSPF under either the router OSPF configuration mode or on a per interface basis. Here we see an example of how this can be configured. On R1, we see that under the router OSPF configuration, we indicate which network we want to participate in OSPF. This is the configuration we've already seen in practice in previous videos. On R2, however, you can see that we've enabled the OSPF process here, and then we go into the interface and enable OSPF for Area 0. This is simply another way to configure exactly the same thing. It's a bit more intuitive because we're applying it at the interface level, essentially saying, I want this interface and its configured network to participate in OSPF. But it has exactly the same result as the configuration on R1. Now, OSPF version 3 is configured differently. There are a couple of ways you can employ OSPF version 3. On R1 here, we have the command IPv6 router OSPF 1. By using the IPv6 command here, we are telling the router two things. One, that we are using OSPF version 3, and two, that we are only configuring the IPv6 address family. IPv4 is not enabled at all for OSPF. Now, once that's done, then you can go to the interface in question and enable OSPF on that interface and put it in the area you want. You do that with the IPv6 OSPF command. Once that's done, OSPF version 3 is up and running using IPv6 only. If you do it this way, you can only run OSPF version 3 for IPv6. You can't employ other address families, namely IPv4, under the same process. And actually, the address family command is unavailable under the OSPF configuration mode in R1 when you implement it this way. Now on R2, let's configure it differently. Let's use the router OSPFv3 command. This command enables OSPF version 3, but without specifying the address family being used. When you do this, you must then specify the address family you want to enable using this command here. Once you do that, you have the option of configuring other address family related parameters in that configuration mode as well. I won't be doing that here. I'll exit the mode and then go into the interface configuration mode and enable OSPF in the same way we did on the other router. So the results are the same in both routers, and an OSPF version 3 IPv6 neighbor relationship is created between these. But this second option in R2 allows you to enable multiple address families if you like, under the same OSPF process. We would simply add another address family command indicating IPv4 here. The configuration on R1, however, locks you into the use of IPv6. So those are the primary differences, practically speaking, between OSPF version 2 and version 3. Now, there are more nuances involved when configuring. I won't mention them here, but we will see them in upcoming videos when we configure OSPF version 3 using IPv6 addresses. So stay tuned for that. For now, I hope you found this video useful, and if you have, please click that thumbs up button. Please check out my website and register for my newsletter. You'll find the links in the description below. And don't forget to subscribe to the channel to get updates to newly published videos. I'm Lazarus at telecomTech. I hope this has been helpful for you, and I'd like to thank you for watching.